Welcome back, everybody, to the fourth day of guided application. Today, we are going to cover the Python unordered data structures as well as some built-in methods. Last week, we finished talking about the order versions of it, which is like your lists and your tuples. We got to work a little bit with that. Today, we're going to talk about dictionaries and sets. The biggest one here for today's curriculum is going to be dictionaries. My favorite data structure is probably one of the most powerful ones, and very important to kind of really understand. But yeah, on top of that, I also went ahead and finished. Oh, I need to pull it in. Give me a second. I finished adding the exercises. Oh, unfortunate. Um, what you call it? I finished pulling in the exercises from um for the rest of the lessons. We don't see it here. Let me go ahead and let me not share my desktop. Give me a second while I pause.
Roger, you're muted.
Thank you. I've been talking for like a whole minute. All right, so as I mentioned before, um, we're gonna go ahead and start with Python unordered data structures and their built-in methods. For those of you that might have already been looking ahead on the curriculum, I did finish the rest of the lesson exercises if you want to get some additional, uh, you know, exercising and run-throughs. Definitely check those out. Um, you might see that some of the assignments that are by default already that's been on the curriculum at the very end might seem a little complex sometimes. If you feel like these are a little out of scope for you and you still don't understand it, definitely try out the lesson exercises within the exercises directory. Those kind of start you off a little bit easier, and they can really get you ready before you actually do the ones on the assignments. But the first one we're going to cover is going to be sets, right? And sets are a immutable data structure, and are unordered collections, right? The biggest thing to note about sets is the fact that they are unique. Right. The unique factor of sets is really what separates it from using something like a two. Uh, because they are unordered, sets are not considered sequences like lists, so they do not support indexing or slicing, right? But they do support something very unique, which is some specific methods like union, difference, and symmetric difference, right? And essentially, what this is, it allows you to compare between two different sets, and it'll return to you whether, you know, for example, if you have set A and set B, you can check, the difference between them. Think about almost like using, if you remember from math class, something like this event diagram where you have one item on the left and one item on the right. And if it's on the left one, those are things that are unique to one set. The right is unique to the other set, and then the purple being what they share similar wise, right? And that's what some of these methods are going to allow us to do is to really compare between the different sets, what they share in similarities and differences, essentially creating membership checks. All right. Now, to create a set, you have two different ways, right? The first way we're going to talk about is very similar to how we instantiated a list, uh, but instead of using the list, we call sets, right? So we use the set method, and it starts with an opening close parentheses, and this will create for you a set. I do not have. Give me a second. I D. We use such a hassle. Uh, Unless you guys are programming. Right, how to connect my virtual environment so I can use the Python kernel for this. But all right, so now that I have that connected, I can run. All right, okay. Why are you giving me a hard time? There we go. There we go. All right. So here, we use the set method, and that instantiates a set type data structure assigned to the mySet variable. And then afterwards, we call the mySet, and we see here that it returns to you the type of what it is. Um, to be more specific, we can and then we'll use the type method around mySets. Right? It's a set class or a type class, a set. Right? This is a very deliberate method of instantiating a set. And another method will be something very similar to this. Not to get confused with the rest of the lecture, because we're going to talk about dictionaries. You'll see that they share a similarity. But another way to instantiate a set is by using curly brackets. And it'll become easier to understand what I mean when not to get confused with dictionaries. And that's because dictionaries get instantiated with curly brackets as well. The way that Python is able to identify the difference between a set and a dictionary is the very fact that the elements within this do not have key value pairs, right? Notice that these are just individual elements. One element at index 0, one at index 1, and maybe I should correct what I say. They're not indexes, right? Because these are unordered. So technically, we have here just a random order of different elements within the set. And then if we run the type on this as well, type set. So both of these do the exact same thing. The biggest difference between the first one and the second one is that this creates an empty set, right? Where this one, you're able to create a set, but at the same time, passing in values. So it does two steps in one, whereas this one, you would have to create the set first by it being empty, and then maybe add values into it. Here, you just skip the set method right off the bat, and you just immediately create the set with actual values in there. Very similar to how we did the list, right? You had the option uh, of doing that with the list, whether calling on its own or instantiating with stuff in it already. But yeah, do I have any questions on how to essentially instantiate a set on either of these two methods? All right. Well, you might notice on the creating sets is if you define an empty set with empty curly braces, Python will interpret that as an empty dictionary, right? So if you want to create an empty set, you have to use the set method, right? The empty curly brackets will be interpreted as a dictionary, and we can see we do print my set. The first time that we create the set, it actually we can print the type, and we see here it returns to us that it is a set. But the next time that so because Python by default will interpret curly braces by itself as a dictionary. So something to take into consideration. All right. Uh, and here is one of the great things about sets, and it's the ability to deduplicate values, right? Uh, and we see that here in real time. We have a set here, and essentially the set is created with duplicate values. We have 1, 1, 2. Excuse me, I gotta sneeze. I apologize. I definitely sick. My son goes to daycare and he brings all his germs that all the other little goobers carry around. Uh, I apologize. That's gonna happen more frequently today, so just a fair warning. But yeah, so we have the set here, and we see here that we have duplicate values. One appears, it seems to be like maybe 6 times. We have A appears twice. Um, I see 5 here at least 2 times. And then we have here a tuple, right? The tuple also has multiple items in here, very similar to what the my set is, but instead of within the curly braces, it's within the parentheses. And when we print these, we see a different result than what we would expect, right? When we printed the my sets, although we added specific items within the set, sets will deduplicate any values that appear more than once, right? So all the ones that were in here, it got rid of them, right? So essentially, when it was creating this, it ran into the first item, which is 1, and it added it in here, right? And the next time it encounters it, it ignores it, right? And it skips it. It pretty much says, well, I already have it in here, so I'm not about to add it again. I'm just gonna go ahead and skip over it. And it goes to the 2. This is the first time it encounters a 2, so it adds it in here. And it moves forward. Notice that there's an A in here, but that's not the next item within here. And the reason for that is because this is not in any specific order, right? Um, if you run this on your computer, you actually might get a different response than what I got. I got AWB. You guys might get ABY. Sometimes you might get the letters first and the numbers. Um, the way that it does this is a little complex. Essentially, it kind of hashes or it gives all of these or puts them in a code depth. The best way of explaining this is saying that these are not in any kind of order, right? There is no specific order. You cannot say my set index 0 and expect to get 1, right? These do not have an order. Every single time that you run this, you might get something different. Uh, no, will not do it for me. It will keep it the same. But if you guys run this on your computer, you might get something different. If you do this tomorrow, you might get something different. So just keep something to keep in mind that this will not give it to you in any specific order. So it's not reliable to use this if you want to have it ordered. It'll return to you the duplicates. So it might be helpful to get something that is only unique for those coding problems that you might see. Where like, hey, grab this string and return a string that's only unique values, then the best way of doing that would probably be grabbing that string and wrapping it around a set type to convert it to a set, right? And that will automatically remove all those duplicate values. That's an easy way of solving that question. That's where it's handy, right? Notice that the tuple didn't do any of that, right? The tuple went ahead and it took exactly how we passed it in here, and it did not change the order. It did not remove any duplicates, right? So difference between sets and tuples. Do I have any questions about the deduplication of values in a set? I see. So, Tristan mentioned that my mic is cutting out a bit. Still cutting, or am I good?
Every now and then.
Okay. Let me go ahead and see if I connect my charger to it. Maybe that keeps it from acting up. All right. Hopefully that helps. One thing that I do want to point out, um, as we continue with this class, I've had a couple people reach out to me, either on one-on-one or whatever, and they mentioned that they're completely lost, right? No naming or anything, but I just want to make sure that you guys are aware that there are people that are just lost in this curriculum, and the reason why I bring this up is because probably after every like topic that I discuss, I ask if there's any questions, and I do not get any feedback back, right? But then somehow I have people message me privately saying that they're lost, which is fine, right? But what's not fine is, you know, that you're on day 4 and you're lost, but you have yet to ask for help. So I encourage you guys, once again, I have to keep saying it. If you guys have questions, if you did not understand a word that came out of my mouth, please stop me. And I have no issue re-explaining it in a way that maybe better suits you. Uh, I'm here to help you guys learn. I want you guys to learn. I can't help you learn if you don't speak up, right? And you don't want to wait till the end of the course, say, hey, just want to let you know, I am still lost, and maybe after day 2 or day 3, I don't know what's going on. All right, that's not the time to be bringing it up. So as I go through this, if you did not understand it, please raise your hand, let me know, and I'll try to explain it in the best way that I can. And just like Tristan says there, what did he wish he could have done differently was asking for help earlier and more often. And absolutely. All right. Next we're gonna talk about some methods that go into the set. And this is gonna be how to essentially add or remove something here, right? The built-in methods that come with the set are gonna be the add and remove, as well as the pop, right? The my set was instantiated earlier. We know that it is a bunch of random numbers and letters, right? And then here we see that we're trying to use the add method to add 500. And when we do this, we see here that it gets added. Now, notice it is in no specific order. Technically, 500 is not less than 6, but it went ahead and just added between 5 and 6 anyways. You might think that it might be added at the end of the numbers, or maybe afterwards. It did not. How it does it, who knows, right? Exactly how it does it. Just know that it does not add it in an ordered fashion. So you cannot expect this to be reliable if you want to find something specifically later on in the future. To remove an element, you do the exact same thing. You do remove, and you call the item that you want to remove, and it removes it for you. All right. So adding something, we use the dot add, and to remove, we use dot remove. Very simple. So this is if you want to specify, if you want to remove something. We also have the dot pop method, which, as you might have already guessed, is very similar to the list one. But we don't specify what we want to remove, right? It removes and returns an arbitrary item from the set, right? You cannot specify an index with pop, right? So here we have item is equal to my set dot pop. Essentially, they're calling the sets using the dot pop method, and whatever item gets removed from the set, it's going to be saved into this variable called item. And then we're printing out both. We're printing out what item we removed and the entirety of the set to see a change. And we see here that what it returned to us was item 1, right? And then we get the set here as well next to it, and we see that item 1 is no longer present. So if you recall, the list removed the very last item in the index. Here, it did not remove the very last item. It chose a random number. We run it again. Now it shows 2, 3, and it seems to be choosing the front of it. But just know that right now it's choosing 2. It might choose something else later. Do I have any questions?
Yeah, if we wanted to choose a specific, and maybe you covered this, but if we wanted to choose a specific number in this set, would we use the index, or would we actually choose to? All right, so we choose the actual number that we want to
Correct.
remove.
Once again, to reiterate, the set is unordered. So you cannot use index, right? And let's actually try to do
Gotcha.
that. Let's
Okay.
try to call an item with the index, right? We here, I'm getting an issue because it already removed 500. But here's my set, right? If I try to do print my set, it'll print my set, right? But if I do my set index 1 to see if I can grab the number 2, we get an error, right? Set object is not subscriptable because there is no address here. There's nothing pointed to that. It doesn't know what index 1 is because there's nothing linked to it. There is no index. There is no possible way to get a specific number by a position and where it's at in the set, right?
Got it.
If
No, thank you. That helps reinforce the.
Yeah, let me see if I can use this method. I wonder if this will work. I haven't worked with this in a while. Nope, it has no attribute get. I wonder if I do 500. I don't use sets too often, so which is why I'm kind of testing some stuff out. But yeah, there's no specific way of grabbing an individual item. You kind of just have to print out the entirety of it, or remove it or add it. If you want to use a number, you might want to do something like number I chose is equal to my set. And then we can say dot remove, and let's remove the number 2. And then print number I chose, right? And it does not exist anymore. Okay. All right, guy. Let's see what the heck happened to my 2. Oh. Yeah, 2's not in here. That's why I was getting the issue. So let's do 1. Let's remove 1. And see what happens to it. Okay, well, look at that. So unlike the pop method, right, where when we did my set.pop, whatever was removed, it was added into the item variable. Notice that when I did that with the dot remove method, it did not save it into the variable, right? This one did, but this did not do it for me. I could not even print it out. It's saying that there's none, right? Whatever is saved into number I chose is none. That means when I removed it from the set, it just disappeared. It didn't even allow me to save it somewhere, like the pop method did. So we're definitely limited here on what we can do with sets. So that's something to take into consideration of when you want to use sets. To be fair, the only time I can think about when I would want to use a set is going back to what I mentioned about deduplicating values in something, right? Let's say you get a list, right? And this list has let's say like a sign up list, like people who signed up for a course, right? I wouldn't want Phil R. I don't know what your last name Phil is, but let's say you signed up 3 times. Why would I want to have my final roster to have your name 3 times? I might want to grab this roster, wrap it around the set, and just get the unique values. Granted, right, there might be people that have the same name, but that's just like a very down and dirty example of using a set to remove duplicates. So stuff like that to get only the unique values of things in other data structures is where the set will really come in handy. I've used set maybe 2 or 3 times, if I'm being honest with you, in the last 2 years. So it's not something that you'll be using daily, but it is good to know that sets is some type of data structure that exists, and then how to use them and why you'll want to use them. Right. Did that answer your question, Phil? Or did I just rant on longer than I should have?
No. That definitely helped clarify. Yeah, and yeah, I was wondering when to use them. So yeah, you helped with that as well. Thank you.
Right on. Okay. So we have that. Let's go ahead. Let me reset this to what it was. And then run this again so I get what it should be at. All right. Okay. So the next thing that we're going to talk about when it comes to sets, and one of the cool things about it is what I mentioned earlier was being able to use comparisons between your different sets, right? Going back to what I mentioned earlier, using the Venn diagram, if we had like set 1 here and set 2 here, we're able to compare using different methods to see what's in which and what similarities these two sets have between them. Right, and that can be seen here with this little handy dandy chart, right? The first one is going to be intersection, right? So that returns the elements that appear in both set A and B. That's going to return to you if you use the graphical representation, the center part of your Venn diagram, everything that both these two sets include, right? So set 1 will be A, and then we will use the dot intersection method on that set. And then within that method, you pass in the set that you want to compare it to, right? So we're invoking the dot intersection method on A, and we're passing in B, so it knows what to compare it to. And this will return to you the elements within both of these sets that they both have, right? And we'll see some real explanations of these in a bit. Union is another one which returns elements in either set A or set B. So essentially, it grabs everything, right? Everything that set A has and set B has, and returns to you both of them joined together. Left set difference and right set difference. These are the exact same method, right? But where you put the set will determine what you get back, right? Right. So here we have set A, and we want to get the difference between set A and set B, right? Essentially, what this will return, right, are elements from set A that are not in B, right? That are not in set B, right? So if set A is numbers 1 through 5, and then set B are numbers 4 through 10, what you'll get back in return are the numbers 6 through 10, right? Because 4 and 5 were in set A, but the rest of the other numbers are in set B. And then vice versa. And maybe it's a little confusing kind of saying this out loud, and it'll make more sense once we actually see it in code. And then symmetric difference is, elements that are in set A or in set B, but not in both, right? Where they don't share similarities, where they're unique to each other. Now, that's enough talking. Let's actually see what it looks like, right? Here we have this variable called my other set. And it's called my other set because, as you see before, we already created a my set earlier. That's the one that we were working with. Right now, this is what it looks like. 2, 3, 4, 5, 6, 7, A, Y, B. Right. What we're going to do is we're going to compare this other set that we talked about earlier to this new set called my other set. Right. Let's go ahead and run this. So it creates it in memory. Right. And let's also print out. Let's print. So we have it here next to us, my set, and then my other set. So we can see them left to right. All right, here we go. We have what we created earlier, and we have this new set called my other set. All right. Now, when we run the my set union, what do you think this is going to return? If you guys think back to what we talked about, what should this return? And honestly, the names of these methods kind of really give it away.
Return all of it, right?
Excuse me. Yes, it's going to return to them all combined, right? So we run this. Notice, first and foremost, it's not in any specific order, right? It's completely unordered because they're still sets, right? Once again, unordered data structures. And then we see here that it has 10, which is found on the my other set, 2, which is here, 3, we find them here as well, right? They're on both once, but they only return it once, right? It didn't return to you duplicates. It appeared in both of them, so it only returned that one to let you know, hey, all these are what's found within the two sets, but it did not return to you duplicates. We then see 4, which once again appears on the left set and on the right set, but you only return 1. 5, which is here. 500 appears right here, right? We then have 6, so on and so forth, right? So this will return to you everything from both set and set B, but they will not be duplicates, right? Because once again, what does sets do? They deduplicate values, right? Deduplicate values. So it'll return all the values from both, but there will not be any duplicates, right? The rules still apply. Do I have any questions on union, how I join them together, and why there is no multiple values for stuff like 3 or 4 or 5? Right on. So yeah, it returns everything from both sets, but no duplicate values. Now, we then have the difference, right? We're grabbing my set, right? The one on the left, and we want to get the difference between my set and my other set, right? And when we run this, you see here that we get 2, 6, 8, and Y. What this is telling you is these are the values that we have in my set that are not present on the other set, right? The difference between these two. Everything else that it does not show to you are things that they share in similarities, right? It's going to return to you what does not appear on the other sets. And then vice versa. If we switch these up, we say my other set dot difference, my other set. Oh, I'm pretty dumb. Give me a second. Happiness heart. Right? 10 and 500 are the numbers that are not present on the might set. Right? They hold everything else, but not those. Right? So you can see there's a difference between both of these. But they will show you the difference between them. Left difference, and then you saw the right difference. Do I have any questions on how this works? Now, when's a practical time to do this? Well, let's check a little example here. Let's say we have students, right? The list of students we have, I see Nicholas, I see Johnny, and I see Lauren. And then we see, let's say we have a survey completed list, and this is holding a list of all the people who have completed my survey. And the only person that's completed is Nicholas, right? Now, if I wanted to grab all the people that have not completed my survey, how would I grab them? Using the difference. How can I write a, oh, let me change this. My apologies. This is a set, right? How can I grab the people that have not completed my survey yet? Yeah, let's try that. Let's go ahead and do students, right? And I want to get the difference between students and survey completed. And when I run this, it returns to me Johnny and Laura. And that's how I'm able to grab people that are currently not present within my survey completed list. If I have a roster of people who already completed something, right? And then I can invoke this method to get a list of everyone that has not completed it, that I do not find within the set. And then maybe say something like print. I wonder if I can do this. Not completed. Let's try this out. Hopefully this works. Not completed. Have not completed the survey. There we go. Right, we say Johnny Lauren have not completed the survey, and there's a more practical way of doing this using for loops, but we'll talk about that in a different time. But notice that I'm able to grab everyone that has not completed my survey yet by using a method like dot difference, where I can compare it to different sets, and then use that to my advantage to figure out who should I send an email to saying, hey, you guys have not completed the survey. Something very similar to this, but that just gives you a more practical example of how you can use the dot difference or the other different methods that come with it. Right? Did this help you guys understand the difference a little bit better? Do I have any questions? All right. Let's go ahead and move forward, guys. And go ahead and comment this out. Next, we have the symmetric difference, right? It's going to show to me the difference between the left and the right set, right? And things that they do not share together. So once again, here is my original sets. Oh, my apologies. Here it is. And then when I run this, we see that 10 is on the right, but it's not on the left side. We see 2 is on the left, but it's not on the right. Then I have 500, which is on the right set, but not on the left, and so on and so forth. It does that to all of them, right? So it's essentially showing you what is unique on the left and what is unique on the right that both of these do not share a similarity with, right? So the difference between both of these, right? And none of these methods can be found within like the other one, right? These are all the unique values within both of those. The difference between these two. All right. Next, what is the example? We have intersection. Intersection, which should tell you where the cylinders show. Here we have print my set, which is the original set we created. We then have a new my other set that's being instantiated here, 3 to so on and so forth. And then we run the my other set within the intersection method, and we see here that we get 3, 4, and 8, right? And this is going to show you where these two intersect. They intersect at the 3, they intersect at the 4, and they intersect at the 8. You do not see 2, you do not see 5, we do not see 6, 7, Y, or B, right? Because they're not found within each other. This is not where they intersect. All right, going back to the Venn diagram explanation, right? The intersection is going to show you where both of these have a similarity within each other, right? Do I have any questions on intersection? Essentially, these methods are just ways to compare your sets between each other to see the differences and similarities between them.
Quick question. So
Yes.
like, does it like work completely differently when it comes to you comparing lists instead of sets?
Lists, if I'm correct, they do not have these types of methods, right? These are
Okay.
unique. These are unique to sets. I can show you in real time. We can say list 1 is equal to 1, 2, 3. List 2 is equal to 4, 5, 6. And then if we say, let's add actually 3 in here to see if we can get the intersection. We should get an error, right? List 1 dot intersection. When we pass in list 2, and we should get an error saying that it's not a set type. List object has no attribute intersection, right? Lists do not have these methods. These are unique to these sets, right? If you want to check similarities between lists, you might have to do this differently. I think a quick way of doing it would say list 1 is equal to list 2. And then we get false, right? It's saying that these are not equal to each other because they're different. If you wanted to check this in a different way to be very specific, you would have to use some kind of loop, which you guys see tomorrow. We'll say like for num in list 1, if num in list 2, print it exists. And then let's make it into an F string. And this is a little out of scope, but there is a different way of doing that for that. See, we see that it printed out it exists for the letter or the number 3, because list 1, when it got to number 3, it checked if it's within list 2, which is true, right? This came back to true, so it printed out it exists and then a number. So there's different ways of doing that. Methods like intersection, difference, symmetric difference, those are unique to sets. Does that answer your question?
Yes, thank you.
Yeah, no problem. There's different ways of doing stuff for different data structures. This is for lists, and these methods are unique and only for sets. All right. Now, we take a look at a set of employees. Oh, I already kind of showed this example. My apologies. These employees, right? It's a set of different employees. It's just a bunch of first names, and then we have another set here where it says completed training. That's probably where I got the idea from. My apologies. And then we see here the difference employees dot difference, and they're comparing it to the completed training. So if we run this to instantiate the variables, and we check this out, it's going to give me a list of the people who have not completed the training, right? And there's a dot here saying that there's like more that goes between these. It's just too much to display, right? The output is truncated because there's a lot to show here on the screen. But we can use the dot difference to do comparisons like that. I showed you guys the example earlier. This is just a much more thorough example of it too. Let's go ahead and clear this output. Do I have any questions about sets or how to use them, how to instantiate them, and how to use their methods, or how they differ from other data structures? We will see sets in the live assessment. Morty, great question. What you see in the live assessment is not the right question. Will we need sets for the live assessment is a much better question. And the reason for that is, I apologize, I'm super sick. You will be given 3 questions. Or for the coding assessment, you have 3 questions. Whatever question Guillermo gives you, I don't know what he has planned. I don't know if every single one of you guys has different questions or how that works. If he just has one straight question for everybody. But the way that you approach the live assessment or the way that you approach any question is all up to you as a developer, right? These are just tools for your toolkit, right? If whatever question you're working with, as I mentioned before, a good example would be, return the unique values that appear within the list. And it might be a list of a bunch of random different data types. You can wrap it around a set, and then it'll return to you all the values are unique because they will deduplicate the values. That's a good way to answering that question. So everything that's being taught here to you guys are all tools that you can use to solve your coding assessment, right? Or solve your live assessment. So nothing here specifically will be seen. It's what you decide to use or implement for your solution. Does that make sense to you, Morty? Yes, no problem. And you might have already seen it, right? I have here a cheat sheet on my desktop. And I've had this for the longest time. I should probably change it. This is I set this up when I first started coding. And that was because I was learning Python and JavaScript. And as you may know already, for those of you who've already been dabbing into JavaScript, the methods and syntax are a little bit different, right? And it was coming to a point where I was forgetting some of the syntax or methods that go with Python because I was doing a lot of JavaScript at the time. And I set this up to kind of just use as a quick cheat sheet whenever I was working with Python. And the reason why I did that is because I had a Google interview. And the interviewer gave me a question. He allowed me to use whatever language I wanted to. I decided to move forward with Python. And during that interview, I completely brain dumped how to access dictionaries in Python. And that looked very unprofessional of me, right? And it wasn't because I'm bad at Python. I had not touched Python in so long. I forgot every single way of doing it. And I was trying to get like the list of the keys, or I think it was the keys and values, and that was an issue, right? And I told myself never again, never again. So I did this for myself, to avoid that. Yeah, let's go ahead and see that in real time. I see your question, Morty, or I believe it's Nick. We can have a list here. List one is equal to, let's say 1, 1, 2, 4. A, A, and then B, B. All right. If I do unique values equal to, let's say, set list 1, and I print unique values, this should remove all the duplicates. Oh, my bad. I didn't add a comma here. There you go. Right. So here's my list of duplicated items in it. I literally just wrap that list around the set wrapper, very similar to how you convert a set into, I'm sorry, an integer into a string, or a string back to an integer. It's the same thing that you do here. It's called typecasting. We're gonna cast this type, which is a type list, into a type of set by wrapping it around a wrapper, and that wrapper is the set wrapper, right? This is what's known as typecasting, right? So yeah, you could do that, and without me having to loop through every single item in here and removing duplicates, I can use this quick shortcut with a set, and it remove any type of duplicates, and then I can go ahead and convert it back into a list, I believe, if I'm supposed to return a list. And see here that it's a list again. So I converted it into a list that deduplicated my values, and then I converted. I'm apologies. Let me take that back. I converted this list into a set, and then from set I reconverted it back to a list, right? But this time when it became a list again, it no longer had those duplicated values. It is similar to converting a set to a list. Thank you. Okay, I got it. To convert a set to a list. Yeah, absolutely. If we change this into curly brackets or curly braces, let's say this is set 1. 1.1. Oh, it is not like that. And then if I did list 1 is equal to list set 1, 1, I can print this list out, and it'll work. But notice, what are you doing? Oh, my apologies. When it did this, what do you think happened here? It automatically deduplicated my values because I converted it into a set. Even though I'm passing in duplicate values like you saw earlier on previous examples, because it's set, it's going to automatically remove the duplicate values. But I am able to convert it into a list using a list wrapper. And when I print it out, we see here that I got square brackets, therefore letting me know that it is a list. So yeah, it goes both ways, right? You can go from list to set, set to list.
Thank you. Yeah. So it looks like it's a good way to clean your data for duplicates.
Yeah, it definitely is.
Thank you.
Yeah, no problem. All right, guys, time is 6:54. We're gonna go ahead and take a 10-minute break before we move on to dictionaries. I'm gonna go ahead and pause the recording. All right, welcome back, guys. Before we move on, I want to share something real quick. So because I have received um some feedback about people feeling a little bit lost, not sure what they're doing or whatever. What I'm gonna do is tomorrow and Wednesday, I'm gonna hold some one-on-one sessions. Um, and I would like to allocate an hour per student. So what I'm gonna do is I'm gonna share a document here into the chat, and then I'll add it later in the Slack channel as well. If you need some one-on-one time, actually let me add it on Slack so it's first come first serve. But if you need some one time, there's 6 slots open from 6 to 9. Go ahead and open up that link and then add your name in there. And that will save you guys a slot so we can kind of talk here in the Zoom channel about any questions you guys might have. Let me go ahead and edit this message real quick. Give me a second. All right. So the sessions are going to be optional. Don't feel pressured if no one signs up or if one person signs up, it does not matter. It's there for you guys. If you guys want to have the one-on-one, is the one-on-one also for JavaScript help also? Yes, we could definitely do JavaScript. Whatever it helps you guys understand the concepts better. If you feel like you just got lost from the beginning, we can, start from there too. I do advise when it comes to these one-on-one sessions, do have an idea of what you want to talk about, maybe a small little list like, hey, these are the subjects I want to talk about, and we can, knock them off as best as possible. Morty, this is in the Slack channel for guided application winter 24. I'm assuming, I assume that most of you guys were in the channel, but in the event that you guys are not, here is the document within the Zoom call. Go ahead and allocate some time if you want it. If, for example, I see Johnny signed up for tomorrow at 6 p.m. If no one signs up for 7, then we would just go ahead and roll into it. If by tomorrow morning no one signs up, you're more than welcome to sign up for any additional time within there. I'm not working within that time, right? So this will all be optional, and I'll make the time for you guys. I do want to make sure that everyone here has the opportunity to ensure they get all the help that they need. If they feel like they're falling a little behind, or they could use some one-on-one time. I know sometimes students might be a little intimidated to reach out for help, and that's okay. So I just want to let you guys know that I am here available for y'all. So please take advantage of it. But with that said and done, let's go ahead and move forward with the curriculum where you guys finish signing up. Are we all still looking at my VS Code? I'm assuming yes. Yes, okay, awesome. All right, so next thing we're gonna cover is gonna be dictionaries, right? And dictionary is gonna be one of the most powerful data structures that you guys will have in your tool belt. I use it a lot for most of my coding challenges because it allows you to organize things in a way that are easily accessible. And once you get more into coding and you start realizing that the way your code is structured can actually affect how fast it runs, you'll come to realize that dictionaries allow you the ability to speed up your code in ways that you couldn't before with stuff like lists, right? So dictionaries are mutable data structures, right? Once again, they are mutable and they're also unordered, right? Unordered. But unlike sets, you're able to access them because of how dictionaries are structured, right? They are unordered collections of key value pairs, right? Key value pairs, right? And that's what's very important about dictionaries and what makes them very easy to access the elements in, is the fact that the key is almost like an address or a pointer that points directly to the value that you're looking for, right? Um, they're not like lists where they have indexes, but they can be treated a little bit close to lists, and we'll see that in real time, right? Dictionaries are not indexed, right? But they're accessible by their keys, right? Whereas in lists, when we were trying to grab something within the sequence, we would use index 0 or index 1. We don't use that. We use the keys, right? We still use the same type of bracket notation, but instead of adding a number for the index, you would add the string, or not the string specifically, you would add the key, right? And these keys can be anything. They can be the strings, they can be numbers and tuples. But the biggest thing when it comes to keys is that they have to be unique, right? So if you have a key that, let's say it's, key of 1, you cannot have another key that's the same, right? It will override the values that were originally saved in that key. So that's very important. So whatever you use as keys, make sure that it is a unique form of data type, right? Dictionaries share many properties with sets, right? Both sets in dictionaries are unordered. They're both wrapped in curly braces, which goes back to the start of the class when I mentioned that if you try to create an empty set with curly braces, Python by default will interpret that as a dictionary, right? So if you want to create an empty set, you have to use the set method, because the curly braces will instantiate an empty dictionary, right? Sets must have unique entries, right? So dictionaries must have unique keys. The values don't have to be unique, right? The values don't really matter. That can be whatever your heart desires. The unique aspect with dictionaries has to be the keys, because that's what we use to access the value assigned to that key, right? Think of it as a drawer, right? In your dresser, or you have this dresser with, let's say, 8, 10 different drawers. Each of those drawers or drawers, I don't know if I'm saying that correctly, English is hard. But each of those drawers are essentially what we would call the key, right? We know how to access the item within a drawer because we just go directly to that drawer. Drawer 1, drawer 2, so on and so forth, right? And then the items within those drawers, those are your values. Those are the values that are assigned to these keys, right? And I can kind of give you guys a visual representation of that in a little bit if you guys would like. But a great example of what could be a dictionary is this license, right? And we can kind of try to recreate that in a little bit. But a license here has key value pairs, right? Who can think of a key value pair here within this license? What would be the key and what would be the value? Yeah, date of birth. Date of birth is a good example, right? Date of birth would be the key, right? That's how we access the value that's saved in it, right? And notice that very similar to dictionaries, as you'll see, they're separated by colons, right? So date of birth will be the key, and the value assigned to this key will be a date, right? It'll be a date type. Same thing with stuff like license number. License number is a key. What's assigned to it is the value, and so on and so forth. So if you guys would like, we can go ahead and kind of recreate this a little bit, or you guys can do it on your own to see how it works. But going to how do we create the dictionaries, before we even try to do this, let's talk about how we instantiate it, right? Just like sets, we are going to use the curly braces, right, as the wrappers for our dictionary, right? Once again, an empty curly brace is an empty dictionary, not a set. So do not get this confused. All right. Just like a list, right, where we can add like empty brackets to create an empty list, we could do the same thing with dictionary. We create empty curly braces, and this will give us an empty dictionary. And see here, we run this. We have these curly braces identifying that this is an empty dictionary. We assign it to this variable name called empty dictionary, and then we print out the type of it. And we notice that we get here class dict, right? Dict for dictionary. Now, just like list once again, how we're able to create an empty list with just the brackets. We can also create lists by adding stuff directly in there. And same thing for dictionaries, right? Here we have the empty dictionary, but on the bottom example, we have a dictionary that's being created, and right off the bat, we are adding values and keys into it. We have 3 key value pairs, right? Notice I say 3 key value pairs. This is a pair, this is a pair, and this is a pair. The pairs are separated by commas, very similar to our list. And between every comma, we have a key value pair. The item to the left of the colon is your key, and the item to the right of the colon is the value, right? When we run this, we get here, we print out the dictionary, right? The reason why it's formatted in this manner is for readability. Typically, when I create my dictionaries, I like to do it like this, where you do open and close curly brackets. The open curly bracket is right after the equal sign. You go into the next line, and each key value pair is its own line. And then after you're done, the closing curly brackets are at the bottom, right? This is what you see more commonly used. This is a much more easier readable format for creating your dictionaries. If you use this format, you are a psychopath, right? Especially when you have like 100 different entries, this is not very readable. This here is a lot more conventional, easier to read. You know that this is a dictionary because it starts and closes with the curly braces, and there's key value pairs within it. Each individual pair is in its own line, separated by a comma, letting your code block know that there is another entry that comes after this comma. If you did this, you would get an error, right? We already see the squiggly lines here, right? Statements must be separated by new lines or semicolon or so on and so forth, right? Because it doesn't know how to interpret this. So you have to add the commas to let it know there's more than just one entry. Do I have any questions about how do we instantiate a empty dictionary or a dictionary with values and keys in it already?
Can you add more than one value?
Yes, kind of. We can, and we'll speak about it in a little bit, but you definitely can't add more than one value. If I wanted to add a list of strings, right, more than one strings, how could I do that? Would I want to do something like this? Bonjour. I'm a weeb, so I can. The only thing I know for another language is like konnichiwa in Japanese, right? This will give you an error. So the way that you would fix this, if you want to add multiple items within this dictionary, will be using other data structures that you already learned, like a list, right? This will take in other data structures as values, right? So you are able to add multiple values in here, but the way that you format them is important. If you want to add a list of different items, then you could definitely do a list. You can even do a set if you wanted to. That is also optional, right? So you are able to add more than one value. It's the way that you are adding it in here, right? If you just did this, where you had 2 strings back to back like this, this will not work, right? Gives you an error. Make sense?
Yeah, thank you.
No problem. Yeah, so this is how we create it. Now let's go ahead and try to recreate this license right here, right? I'm gonna go ahead and say license is equal to open and close curly braces. This is how I like to start my dictionary. I open up the curly braces, and right off the bat, I press enter. So it opens up where my code block should begin, right? This is the exact same format that I showed you guys here. And now from top to bottom, let's go ahead and take it one step at a time. All right, we can say license number, and then we will add, there's dashes in here, so this probably won't be an integer. This might be a string. So I'll say P142 dash 4558 dash 7924. Right, that'll be my first key value pair. Next will be the date of birth. I can add the OB, I can spell it out if I wanted to. I'll just use the acronym. This is a date type, but I'm not gonna get too in depth into dates, so we'll just add it in a string format. 1987, right? Expiration would be, once again, 11/14/2023. And you would keep doing this to grab everything that you want to add in here. I don't know what ISS is. I believe it's issue date. 2019. Let's go into a number. Let's use the DD at the very bottom. DD, we can add integers. So 201-602-1099-3. Oh, there seems to be a D in here, so I guess I can't use this all integers. But the point is, notice that I'm able to add stuff like integers as well. It doesn't have to be a string. It could be an integer. You saw already that I can make lists. Notice that I can even make an empty list, right? So DD could be an empty list. It could be floats. It can be booleans. It could be sets. It could be tuples, right? Whatever you want to do, you can pretty much save it in here, right? The key value pairs. What matters is the fact that these have to be unique, right? The keys have to be unique. And I'll end it there because I think you guys get the point. All right. So moving on. We talked about how to instantiate dictionary, both empty and with data in it. We talked about the stuff that goes in there, but now let's talk about how to actually access the items within the dictionary. As you recall, I mentioned that you can use bracket notation very similar to how we did it for lists. And that is true, right? But the difference between the bracket notation is that instead of calling it by the index, because it is an unordered collection of key value pairs, it doesn't take indexes specifically, right? It's going to take a key, right? The key is the way that you get to the value, right? That is the address to that value. Here we have the English Fresh Dictionary, which we see we have 3 key value pairs of hello, world, and thank you. This syntax, what this is doing, it is accessing the key value pair of hello. This will return to me the value to this key. And when I run it, you see here that I get bonjour, I don't know how to say it, back, right? If I assign this to a variable called greeting, this is going to run the dictionary by accessing the key, and whatever comes back from this key, which will be the value, is going to be assigned to my greeting, and then I can print out greeting, and I can still do the exact same thing, right? We can grab items using the dictionary and assign them to variables, right? So how do we access it? We call the name of the dictionary, and then we open and close square brackets by passing in the key within it. Now, that accesses it, but what if I want to update my key value pairs? Well, very similar to how we access it and how we change values in dictionaries, we can do the exact same, or sorry, not dictionaries, in lists, we can change values in dictionaries doing the equal sign. So here we're accessing the key value pair of hello, and then I'm going to reassign the value of hello to konnichiwa, right? And then if I print out the English French dictionary, notice here that hello has now changed to the Japanese version of hello instead of what it was earlier, which is bonjour. Right, so to change values in your dictionary, you have to call the key that you want to update and then use the equal sign to assign it a new value. Do I have any questions about accessing or changing values in your dictionary?
Can you only access by the key? You would never try to access by the value, right?
Yeah, if you try passing the value here in these brackets, you're not going to get what you're looking for, right? The value won't work because the key has a address to it, right? I wonder if I can do this. If I do, let me run this again. I'm going to try and print out the ID for this key. I wonder if this will show it to me. Print ID. There we go. This is the address, right? It uses this string on my key as a placeholder. Very similar to how URL patterns work, right? When you visit facebook.com, right? Facebook is the URL pattern, right? But that's just so it's readable to us, right? In its hood, it converts that word Facebook into what we know as an IP address, right? But imagine if we didn't have placeholders like the word Facebook. If you wanted to reach a website, you would have to memorize this long IP address to get to that site, right? And that's not very useful for us as day-to-day consumers of the internet. So we created URL patterns. So where we essentially connect a word to an address. So instead of calling the address directly, we can just use the word as a reference to the address. And that's what the key is, right? It is a reference to the address of wherever the value is saved at. Make sense? The value does not have that, right? The value is just data, right? The key works as its address. Make sense?
Yeah, thanks for clarifying.
Awesome. Do I have any other questions? And I see here, Morty, any notation in Python for any dot notation? No, right? There is no native dot notation for Python when it comes to dictionaries. You must use the square brackets. Does that answer your question? You will see dot notation later. And dot notation is going to be used in classes. And you're probably asking this because you're familiar with JavaScript. Is that correct? Yeah. And here's what I was trying to get at when it comes to JavaScript and Python. JavaScript has two versions of objects, right? Let me look up the exact name. There is literal objects and there's another term for it. Let me see. The two types of objects in JavaScript. It's literal objects and okay, here we go. It's object literals is the name of it, right? Those are your key value pairs with curly braces. And then there is constructor functions, right? Which are not exactly objects, but what you're referring to is called an object literal, or yeah, I believe it's an object literal in JavaScript. What we call that in Python is a dictionary. Now, in actual object in Python is called a class, right? I don't know why they do that differently. Let me see if I can find you this. Right, we have JavaScript objects, right? And JavaScript objects, they can use dot notation to access certain data variables, right? And then they have methods as well. This in Python is known as a class, which is out of scope for this program, and you will learn in foundations of programming or in the immersive program if you guys move forward with it. But this is known as a class in Python, right? This is not an actual dictionary. Let's see if I can show you a JSON object that's similar to Python. Object constructors. Yeah, there are two different things. I wish I could find it for you. What do I type in? Object literals. JavaScript. There you go. Okay, JSON objects, here we go. So here is a JSON, right? You're thinking, so JSON is the equivalent of dictionaries for Python, right? They use the curly braces as well, and they contain key value pairs, right? And then you have what you saw earlier, where it's a class in Python. So not to get confused with that part of JavaScript. They're different. I don't know why whoever created all these languages, man, they like to do their own thing, right? Everyone wants to be an individual, but they're different. But to answer your question, no, you cannot use dot notation in dictionaries in Python. All right, moving forward. So we talked about assignment properties, right? Key value pairs. Here we have let me redo this back to where it was. We have the hello. We're going to change the goodbye to au revoir. I believe that's how you say it. When we run this, you get, oh, my bad. We didn't change it. We create it, right? Goodbye was not originally in our dictionary. So to create a new key value pair, you literally just call the dictionary name. You open and close brackets and just add your key in here to whatever you want it to be. You don't have to do something like dot append like you do in lists, or insert or add like you did in sets. To add something new into a dictionary, you use the bracket notations and just deliberately pass in whatever you want to call this key and the value that you want to assign to it. And now we see here that when we print out a dictionary again, it now has a new key value pair in here of goodbye and au revoir. Does anybody have any questions about adding new key value pairs in here into a dictionary? We talked about how to change one. We talked about how to update a already existing key value pair, and we talked about how to create another key value pair, right? And then we'll talk about delete in a bit. But yeah, so those are the adding, updating, and the accessing portions of dictionary. Now we can also, as you saw, we can update a value, but we can also change what type of value that is, right? Here we have the key of hello, which originally had bonjour, right? But notice here that we are now updating that value to something else. And notice that the data type is completely different. It's no longer just a string. Now it is a list, right? It is a list of strings. So this dictionary has key value pairs where the first key value pair of hello is a list of different greetings. All right, so we're able to overwrite existing values with other types of data types or other types of data, right? Now, and you already see it, I guess, but how do we access the information within this dictionary? And now we have another layer of complexity, right? It was easier before when we just had a key that had one value, we would just call the key, right? Let's remove this. If I run English French dictionary and call a key of hello, I now get a list, but I only want to access salute. Well, to access that, now that we have a list returning, this is essentially returning a list, right? I wonder if I can say print ID and then run this. Oh, not ID. I meant to type. There we go. Notice that this returned a list to me, and I can even choose the type or check the type by using the type method. And it shows me it is a list, right? This value is a list. So to access items in the list, going back to last week's lesson, is we use bracket notation, but we use indexes. If I use index 0 right after that, this will return to me the first value within this list. If I wanted to grab the second item, which is on index 1, I would do index 1, and I get the salute. Essentially, what this is doing is we're diving in deeper into our data structure, one layer at a time. The outer layer is a dictionary, right? Within this dictionary, we have a key value pair. The next layer is a list within this key value pair, right? So we have to dive in first. We want to go deep into our dictionary so we can grab that list. And we do. And now that we're deep in here, at least one layer down, then we can print items from that list using the index notation, right? You still have to call this key, right? Because they won't know what the heck you're trying to access using index 0. If I do this, I'm gonna get an error, right? It doesn't know what I'm trying to grab. Like, I don't know what the heck index 0 is because it's looking at the very top level of my dictionary, right? And the top level is only grabbing key value pairs. So to grab stuff in this list, I have to dive in one layer by going into this key of hello. And this will return to me the next layer, which is going to be a list. And now that I'm within here, I have to work this list as it is a list by using the index to grab an individual item. Do I have any questions about accessing nested lists in a dictionary? Any at all? I know this might be a little heavy for some people, and that's okay. I just want to make sure there's no confusion. All right. Silence is compliance. We're gonna go ahead and move forward. So that's how we access stuff in a list. Now we talked about deleting stuff. How do we delete things? Well, fairly simple. You use the DEL method, right? DEL method. I believe we did the same thing for lists as well. But you essentially use DEL to let your code know that you want to delete something. But what do you want to delete? I want to delete the world key value pair from this dictionary. And when I run it, world is no longer present, right? The key value pair world is no longer present. So we know how to create a dictionary, how to access a dictionary, how to update a value, how to create a new value, and how to delete a value in a dictionary. Any questions about dictionaries before we move on? All right, right on. All right. Now, the next thing we're talking about is the method of keys and values, right? These methods are used to access everything that's either a key or a value. Sorry, I was sneezing. All right. What this is going to do, guys, is going to return to you a list-like data type. And I say list-like for a specific reason. right? And let's see it in real time so you understand what I mean, right? I'm gonna run the dot keys method on this dictionary, and you'll see that I get this. It says dict keys, right? And it's open and close parentheses. But inside the parentheses, it is the list of all my keys that I have, right? Hello, thank you, and goodbye. It is just the keys. And I say list like object because it technically did return it into a list. But if I do print type on English French dictionary dot keys, it's going to give me a different type, right? And we see here that it's not specifically list, it is dict keys. It is not a list, which is why I say list like. Well, Roger, can I access all these keys individually? Let's check it out. All keys is equal to English French dictionary dot keys. This is going to grab that list like object of keys and save it into this variable. Now, if I say all keys and use index 0, you'll see, oh, actually did not get to me. My apologies. Yeah, it did not let me access it. What I should be able to do for keys in English French dictionary dot keys. Let me try something out. This should work. Keys. There we go. And this will come more into, you'll be able to understand this a little bit more once we start talking about for loops. I can loop through the list. I can't access them directly, but I am able to loop through everything and print it out. I can even do a membership check. I can say, I believe if hello in all keys, print it is in here. Yeah, right. I can even do a membership check, right? So it does return a list-like object, but it's not specifically a list. I wasn't able to graph stuff by the index, right? But I can check if there's something in there, right? And I am able to loop through it. And we'll talk more about loops tomorrow or Thursday. So it's not exactly list, but it's very close to it, right? That's something to know, right? It is not a list. It is very similar to it, but it's not a list. And just like we were able to grab all the keys, we can do the exact same thing for values. And we see here that it returns to me the values in this dictionary. The first value, as you guys already know, is a list. All right, so value 1 is a list. Value 2 was merci. And value 3 was au revoir. All right. Once again, a list-like object. I'm not able to grab it by indexes, but I am able to check if stuff's in here or even loop through it and so on and so forth, right? But this should give me an idea. If I want to check values within dictionary, this is a very easy way of doing it, especially if I want to loop through stuff, which will come in handy later. I can do that as well. So that's keys and that's values. The next one, which is just as helpful, if not more, is using the dot items, right? The dot item is a way of combining keys and values and grabbing both of them at the exact same time, right? It will return to you the keys and values together in a list like, this is a typo, list like object of tuples, right? Using this items method. When I print it out, we see here is my list like object. The very first item that I have here is a tuple. And this tuple has two things in it. The first one is hello. And the second one is the value, right? Which is bonjour and salute. This is the key value pair that I grabbed here within the first tuple. The second tuple is another key value pair of thank you and merci. And the third tuple is the goodbye key with the value of au revoir. So all three of these are methods of accessing the data within a dictionary Which one you use will depend on what you're trying to achieve, whether it's going to be just keys, just values, or if you want to grab both of these. And Thursday, we'll talk more about how to iterate through every single one of these individually and how we can use that to our advantage. Do we have any questions on how to access all keys, all values, or all items? All right, so compliance. Let's go ahead and move forward. The next thing we're talking about is some helpful methods that we can use with dictionary. And honestly, my favorite one within these methods is going to be the first one that we see here, which is the get method. Very powerful. Really enjoy it. And the reason why it's so powerful is because it gives you a default for a response. Right? Here we see the syntax for it. It uses the name of the dictionary. And then afterwards, we use the .get method. And it takes two arguments, technically. One is optional, which is a default. But the first one is mandatory, right? The default, by default, I believe it's none. I want to say it's either none or zero. And we'll see that in a little bit. But you're able to override it. And I'll show you why that's important, right? Here we have the English-French dictionary, right? Dictionary that we have created before. We know that we have certain key value pairs in here, right? We have, for example, the keys, we have, let me remove this. We have hello, thank you, and goodbye. But what's going to happen if I try to access this dictionary and grab something that doesn't exist? Well, the biggest issue is I'm going to get an error, right? And this error is going to say that it does not exist, right? Returns an error when the key value doesn't exist is what my notes here. But notice here, key error library. It won't even tell you what this error is. It's just saying, hey, there's an error here, right here. That's it, right? And that's an issue. And the reason why it's an issue is, let's say you have a line of, a code, a program that's like 50, 60 lines long. When you run into an error like this, it'll stop your program, right? It'll stop your program, and a lot of things are going to fail, and that is an issue. So by using the .get method, you allow your code to have a way to handle this error, right? Instead of just stopping your program abruptly like this, this get method gives you an option to return some kind of other value to handle this issue. So it won't stop your code. It'll actually know how to take care of it. And we see that here in real time. We say English dictionary.get. We pass in the library key, which we know does not exist. And then we give it a default of not found for its return statement. And what this is saying, right? If I want you to grab library, but in the event that it does not exist, I want you to return to me not found. And when we run this, it does not give me an error. It does not stop my code. It gives me a response, right? That's usable, not found. And then I can do some logic for whatever if I encounter this response. But what this allows you to do is be able to access dictionaries freely without the concern of what if this item does not exist and it messes up my code, right? That's why I think the .get method is so important and so powerful to know when working with dictionaries, right? So if I don't use the found, I believe it's going to return none, if I remember correctly. Oh, it returned nothing. That's cool. All right, well, it returned nothing. Let's actually save this to a variable. Value 1 is equal to get library. And let's go ahead and print out value 1. Let's see if this gives me something. It should say none. I knew it. It does show none, right? So because it returned nothing, it's an absence of data, therefore it's of none type. So there's none in value 1, which is why when I try to print out value 1, it returns to me none. There's nothing in here. So by default, it'll return nothing to you. But it won't cause an error, right? You saw how I didn't add a default, but it still didn't cause an error. It just didn't give me anything back at all that was workable, which is why it's always good to kind of give it a default here, like not found. So we have an idea of what happened, right? Because it's not very useful to not get any information back. All right. So that takes care of that. Next, we're going to talk about the pop method. And I don't know why this is here. This is adding the bonjour and salute. But then we can use a pop method, which is going to be very similar to the pop method from list, right? But notice here that we're passing in the option of not found, right? It attempts to pop hello, and we give the not found as another optional response in the event that hello does not exist. And if we print hello pop, we see here that when it pops it, it saved it to the variable called hello pop, and I can print it out and it shows me that the value that was removed is no longer within the English French dictionary. And I can even print that bad boy out and show you the before and after. And see here that the hello was saved into hello popped. I can print that out. Here's the value that was saved in there. And I can print out the dictionary as well, and it's no longer present. Right. So pop, very similar to grabbing a key value pair, but this allowed you to remove something and then pass in a parameter where it allows you to handle any kind of error that you might encounter. Do I have any questions on the .get method or the .pop method? All right, time is 6:50. I'm sorry, 7:51. We're gonna take our next and last 10-minute break. Once we come back, we will finish this lecture. And then we have some assignments that we can work on. 7:52 now. All right, guys, let's go ahead and finish off today strong. Let's continue with the rest of the lecture. So we saw the pop method, we saw the get method. We're going to continue. We have our new English French dictionary here. I just read this, so we now have some new entries. We have bathroom, we have library, cookie, milk, green, and chicken. All right, this is a new dictionary with the new entries. We can print it out and see what it shows me. And yeah, so now what if I want to update a dictionary? Well, we have the .update method. The original dictionary we have does not have that much. We only have the thank you, goodbye, and hello, right? But let's say somewhere online I create a separate dictionary that diverges from my original, right? I have some additional French words I want to add to my original dictionary, and we can use .update to do that. We take here the dictionary that we want to update on the left side, and on that dictionary we invoke the .update method, and we pass in an entire new dictionary within it. And we run it, we see that the thank you, goodbye, and hello were successfully updated within the as I was. Let me rephrase that. The original dictionary was thank you, goodbye, hello. Now it's updated with the new entries from New English French Dictionary, right? So essentially just combine both dictionaries. And then which one went into which was used by the update method, right? And that's important to know because you might overwrite other stuff depending which one you jump onto which. So if I have for example, the original one already has goodbye, which is au revoir. But if the new one has goodbye and it's I don't even know a good goodbye, adios. Adios here. When I add that to my English French dictionary, you'll see that it's going to override oh, it's not going to? Oh, that's actually very surprising. Why is it doing this? There we go. Goodbye, adios. We're gonna update English French dictionary. We passed in. Run this. There we go. There we go. Okay. It updated this one, but for some reason we have two goodbyes here. I don't understand why. I think could we misspell this here? There's a typo here. There we go. Let's go ahead and run this again. There we go. It overrided that goodbye. All right. So it's important that you know which one's coming onto which, because the new dictionary you're adding to it is going to override anything in the previous dictionary if it already exists. Additionally, on that, it's going to add any new values that we have. So something to keep in mind, knowing which one you're adding to which and how you're adding it. But essentially, this allows you to update an already created dictionary with a different dictionary. Do I have any questions on the update method? Let's do this. Jesus Christ. Okay. Do I have any questions before I move forward? I apologize for the typo. Goodbye was already in here on the new one, but it was typing different than what the original was typed in. I'll have to fix that. But yeah. All right, so here we have the English French dictionary. We call hello. It is hello. It exists within the dictionary. And then we go ahead and pop hello. And when we print out the English French dictionary, hello is no longer present. So you don't have to say this into anything. You can still pop it. And we'll see here that it still works. When we try to use the get method using hello, we see here not found. Thanks to the get method, we no longer get errors in our code. So get method, once again, very useful, very powerful to avoid errors of keys that might not exist. And then pop item. I'm actually not familiar with pop item. That's actually new to me. It looks like pop item, it's going to remove chicken and pullet, green vert, milk, late. Let's see if I print out English dictionary. Okay, so pop item, I guess it's removing an item every single time as well. Very similar to pop. And notice here that every time I run this, it's getting smaller. It's gonna be random. So we don't add something in there, it'll just keep doing it over and over again. And make this, thank you, goodbye, hello. All right. So we have pop, we have get, we have pop item, we have update, a bunch of different methods that you can use for your dictionary. Very powerful, very useful. And there's one more, which I don't believe we saw, which was the clear method. And essentially it's going to remove all items from the dictionary. If I remember correctly, the list one should have it too. I can't think of a reason why you want to clear it in dictionary, but you do have that ability. Do I have any questions on any of these dictionary methods that were taught throughout this class?
I think I have like a pretty random one. Like, is there a way to use a key to access multiple keys to access the same as a value? Am I saying the right thing? 'Cause,
Uh, So you're saying multiple keys, like key 1, key 2, key 3, and they all have the same value, or they all pointing to the same value? Is that what you're saying?
Kind of like how the driver's license example, there's multiple keys on that one driver's license, but let's say you wanted to access it within a database, it would bring up that person's profile.
Ah, yeah. I'm assuming you're talking about nested dictionaries, which is actually a topic for Friday, but I can answer your question now. So if I had, let's create a new code. I could have person 1 is equal to name, and this will be Philip, right? And then I could say age is going to be 27. Person 2 is equal to, let me go ahead and copy this and say paste, and this time I'm going to say Alex. And Alex is 80 trying to break the tech. Let's get it. Right. And then we can say all people. And you could do a dictionary where you have Philip can be the key, and then the value will be person 1. And then you can have Alex as the key, and you can have person 2. All right, and then we can print out all people. And we see here that Philip, and it returns to me all his information. Then I can have Alex, and it returns to me all his information. Does that answer your question?
In a way, yes, but still, so like let's say you added like another key. You'd have to
What
add
key?
a value into it. So like can you add another key to access person 1 in a certain essence or no?
Yeah, you could. We could say random and say person 1. They can have the same values. Now, which was pointing directly to this one? Only this one is. Does that make sense? Essentially, there's 2 key value pairs here that have the same value, but the keys are different. That's the same as saying person 1 is equal to whatever this is, and then person 3 is equal to the exact same information that person 1 has. You will essentially have 2 different ones, but they both have the same value. If you're referring to maybe saying Philip and Alex like this, having 2 keys that point to the exact same pair, no, that is not possible. It's only key value pairs. The values can have multiple data in it, but the key has to be unique. They cannot have 2 different people pointing to the exact same pair, but you can have 2 different key value pairs that share very similar data. Very similar to how you see here on these 2 variables. These are 2 different variables, but they both have the same information in it. Make sense?
Yeah.
Hopefully that answered your question to a certain extent. All right. Common operations across data structures, and these are going to seem very similar because we've already covered them. But we're showing you how you can also use them in these new data structures that we're talking about, right? We have a set here, and just like we saw earlier, a set is curly braces, very similar to dictionaries, but now you can probably see the difference is dictionaries have key value pairs, but sets don't. They're just individual single items separated by commas, right? This is not a dictionary. This is a set because they lack a key value pair, right? We're taking this and they're running the max method on this, and it returns Z16. Why is that? Well, it's going to return to you the maximum value contained in the collection, but it's a little weird because technically these are strings and there's words in front of them. If I have my set 2 is equal to 1, 2, 3, 4, and I try to grab the max for my set too, this will work a little bit more uh a little bit more appropriate to the example, right? It will return 4, but the other one that has letters in it, it's doing something weird. And I want to say the reason for that is because of the letters and their ASCII values, which is a little out of scope. But what I mean by that is letters, ASCII values. Is that every letter has a numerical value that it holds, right, in this ASCII table. And this is how the computer can read it. For example, Z here, the numerical value for Z is 90, right? And the numerical value for A is 65. And both lowercase and capital case ASCII values have their own respective value. So they're different in the computer's eyes. And I think that's why we're getting that weird functionality here. So we're seeing that the max values returning is Z, right? Even though its numerical value afterward is 16 and there's like 19 here. If I'm correct, that's the reason why the max one that we're getting here is Z16. But in essence, essentially what I'm trying to display here is you can use max methods on stuff like this, right? The max method is being passed in here on both of these. And for strictly numbers, we were able to get 4, right? When we added strings in here, it was able to get the max, I guess, numerical value for these strings, and it returns Z16. So you can use methods like this, right? And the same can be said with the min method, right? Here we have the min. Notice we get A18. Once again, I think it's going back as well to the numerical value of this character of A. But min does work, right? We can use min and max for stuff like sets. If you remember, I think we used sum already as well. We have a list here of different integers. We pass in the sum method wrapped around the list. And we see here that's going to take all these numbers. It's going to add them up together, returning to you the sum of everything within this list. All right, so that's pretty cool. All right, and then for the dict, we have stuff like length, which you've seen already. But length is going to return to you the size of whatever this dictionary is, and it's counting the key value pairs, right? It's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So length should return to me 10, right? It returns to me a number, letting me know how many key value pairs are within the dictionary. What if I did my dict dot keys, which technically should give me the same thing too, because there's 10 keys in here because there's 10 key value pairs. But it still works on stuff like keys dot values and so on and so forth. And last is going to be the sorted one, which you've already seen as well, with the flag of reverse is equal to true, right? It's going to sort it by the key, right? By the key. By default, it's sorted by the keys. I believe we can do dot values and just sort it by the values. And yeah, it works just as I predicted. We have 9 to 0 because we have reverse is equal to true. So you're able to sort it by keys or by values. But by default, it will sort it by keys. Right? Pretty cool, right? Do I have any questions on these methods and how they can be used with these additional data structures that we've been talking about? All right. That's going to cover today's class, guys. Today we talked about tuples and we talked about dictionaries. The assignments look a little bit different today. If you click on these, it's going to take you to a replit, which for some of you guys, this should look a little bit familiar. I believe some of the assignments, I believe like intro to coding probably has these as a pre-work. This will allow you to work on the assignments. This is for counting the characters, right? So write a function that takes in a string of lowercase characters and returns an object containing the count for each letter in the string, right? So here we have an example. The string is B, D, A, C, D, A, and then they grab every single word in here and add a count for it. I'm not. Let me go ahead and pause. But yeah, so you'll find these here. Time's gonna be 8:21. I'm gonna give you guys 5 minutes to try out exercise 1. And then we'll take a volunteer. Actually, let's do this. Let's take the next 20 minutes to actually do exercise 1 to 3. And then after those 20 minutes, we'll come back and use the last 20 minutes to get some examples and volunteers for these 3 exercises. So let me go ahead and pause the recording. You should all be looking at my screen here. And if you guys want to work on the updated curriculum, I have been updating the curriculum very often, almost every single day. And you don't want to redo your code space, that's okay, right? There's a way of handling it. And the way that you do that is by either one, recreating the code space, right? Or what you're going to do, right? You can come here, recreate the code space, or what I recommend you do is grab, you're gonna go to here, and you're gonna grab the updated files that you want to add, right? So if you were to come here, let's say you only have the first 2 lessons. You're gonna go to the file that you want to add to your code space, and you want to click on download a raw file right here at the very top right of this. Right, so you're gonna grab this file. It's gonna download it to your computer. And once you download it, what you're gonna do is you're gonna go back to that code space that you're working on. And all you're gonna do in that code space is open up your documents folder on your computer and then just drag and drop it into the directory, right? By directory, I mean over here on the left side, where your files and folders should be. All you're gonna do is literally just from your document window on your computer, wherever your downloads are at, just grab that file, you download it and drag it straight into exercises. And that should update your thing. And I can show you in real time. Platoon. I can't type to save my life. Right, I would go to exercises. I want to grab lesson 2. I download the raw file into my downloads. I'm gonna show you my downloads, so I'll keep that out of the window. But all I'm gonna do is drag it all the way into my exercises, and we'll see here that it populates and it opens it up. And now you have access to the new files, right? So now you all know. Go ahead and continue working. All right. I was looking through the exercises because I forgot what I created, and I saw these are very simple ones. So I'm pretty sure for the most part, you guys should all be done with them. Does anyone want to volunteer for the exercises? Talk to us their code. I see here, Morty, you passed in the answer to something. Is there a specific reason for that? Oh, like no context. Anybody? Anybody?
I can do 1 and 2. I never finished 3. I kind of got stuck on exercise 3.
Sure, let's get it.
Okay. Let me share screen.
I will say the rest of you guys are a tough crowd, man. I'm trying here. I'm trying to get you guys to participate as best I can, but I don't know if we're just all just shy or what's going on. But all right, let's get it, Johnny. Let's see what you got.
Let's see. More reps to practice, right?
Yeah, no, of
Can you
course.
see?
Yes, I can.
Okay, for exercise 1, what I did was I made a function with 2 parameters. So I named the function 2 sets, x, comma y. And then the next thing I did was I went back to see what method would be used to compare the common elements of a and b, or x and y. So I use x dot intersection y and set it to a variable. And then use the return part of the function so it can be called again. And then I printed my function 2 sets, put the parameters set 1 and set 2, and then the output was the expected 3 and 4.
Right on. Like to see it. Good stuff. I just saw I now I understand your response, Morty. I was looking at the wrong exercise, which is why I was so confused. Like, like why'd you add that? But thank you. All right. Good stuff. Next one, Johnny. Let's see it.
All right, exercise number 2. In this one, I figured you only need 1 parameter. And I named the function duplicate or dope, and then put x as the parameter. And then I used the method set to get rid of any of the duplicates. So, and I assigned it to the variable new set, then returned new set, and then printed the function dupe with the parameter list of duplicates. And then the output came to be exactly what was expected.
Okay, good stuff. Only comment I have about your code is the defining of your functions, right? Let's not put a space between the name and the parentheses.
Okay.
It just looks like I don't know. I've never seen anybody do that. Maybe with a typo. It just looks weird and off to me.
I'll try to make a habit not to do that then.
It's okay. Yeah, normally we don't have like a space between there. But still
Okay.
good stuff, man.
And then number 3 got stuck. This is where I got left off. I figured I can explain what I got here, and then but
I
unless someone
see
else wants to
that.
try.
Yeah, I see Morty said 3 is easy. I'm assuming Morty, you can't jump on the screen and explain it to us. So, yeah, try to go ahead and Johnny, see if you want to give it a shot. Once again, the exercise 3 space. Remove that space. Remove that space. That's okay. Yeah, so you're on the right track, right? It takes a set and an element. So we know that we should probably have 2 different arguments in here or parameters. And then we have to check if it's not in the set, right? So how would we check if the element is not in the set?
I'm pretty sure there's a method we learned. I probably just forgot what it was.
Yeah, it's a membership check, right? Do you remember that? How do we check if something is in or not in? And I kind of just gave you the
So it'd
answer
be
there.
like not in or in, right?
Yeah, something very similar to that. Now let's actually add the variables in here. So we can say if element, right?
So if element is not in set, right?
Sets is what we call the parameter. So we have to add sets. Yeah. So if element in sets. So right now, this code is saying if element is actually in the set, right? But what is the question asking from us?
If it's not in it.
Yeah. So if element
not
not in sets.
and sets return. Well, it wants to add, right? So add it. So yeah, return set dots add.
You notice why is set green? Right. The parameter, the way we named it was set. All right.
There you go.
Set is a reserved word, which is
Okay.
why it was giving you Korean.
Mhm.
But I don't know if this will work. 'Cause we're trying to add something while we're returning it. It's better if we add it first and then we return it, right? So that first line, we say if element is not in sets. If this
Mhm.
passes, we need to add it. And then after we add it, we return it. So let's just break it down line by line like that, right? So you were on the right track, but maybe separate the functionality there, right? So line 2 right there should be what? What should we do here?
So if it's not in here, then it would go to an else statement, right? The else part of it.
Not necessarily, right? We're saying,
Mhm.
right here, we say if it's not in the set, then we need
Mhm.
to add it,
Add it.
right?
Mhm.
We need to add it. So right here, this is gonna pass. It's not in there. So if it's not in there, then we should add it.
Okay.
So yeah, sets dot add, and you were already on the right track. The only thing I was trying to get you to do is kind of just separate the functionality so it's not on the same line. Because I believe if you try to do some stuff like that, it might give you an error. But it's better just to do it this way, especially starting off, so you can visualize what each line is doing. But
Okay.
yeah, there we go. Sets dot add elements, and then what do we do?
Then we hit return. Well, we'll set it to a variable and then hit return variable. So it'd be, think of say set 2.
Sure. We could do that. This honestly should already update the set anyways. So you
Okay.
could just return sets. But I mean, this works just fine too. If you want to create a new variable called set 2, you definitely can.
And then I would print x for size 3 with sets 1 and x. There it is. Sweet.
It's none.
Oh, wait.
This is saying it's none. Why do you think that?
I'm assuming it has to do with something to return, right?
Well, yeah, it's returning whatever set 2 is. But
Uh-huh.
what this is telling you is that set 2 is none. There's nothing in here. So
Uh-huh.
because there's nothing in there, there's something that happened here when we were creating it. So maybe what's happening here is we're having an issue when we try to add elements into sets, and then simultaneously we're trying to add it into a variable.
Okay.
So it might be better if we just remove this part here and just return what sets is. So we can say sets dot add element and then return sets, right?
Okay. Like that?
Try that. Yeah. Go ahead. Let's remove return from here.
Mm-hmm.
And then on the next line, do return sets. Try that. There you go.
Okay.
Right. And,
So
and this
can,
is what I
can
was
you
trying to
explain that though? Of why that's that reason?
Yes, that's going back to because you initially did that. You remember I told you like, yeah, you should probably, separate the what's happening here. You're trying to return sets dot add element. So what you're doing there is at the same time you're adding something into sets, you're trying to return it. And I recommend it to you maybe separate that functionality
Oh,
into its
okay.
individual line, right? So here, this line, all it's doing is adding the element into sets. Once this line's done running, then we can go to the next line and return sets, right? So taking it one step at a time, you're
Mhm.
trying to do multiple things on one line and it wasn't understanding what you were trying to do, right?
That makes sense.
Right. And then you also try doing that very similar to whenever you did set 2 is equal to sets dot add element. You try doing this. Let's see if I can print it out.
Uh-huh.
You try doing this. So it was trying to do two things at the exact same time. It was trying to
Okay.
add the element into sets. And then at the same time as you're trying to add it, you're trying to create a new variable, right?
Uh-huh.
And it didn't work, right? It returned none, which is why I told
Yeah.
you maybe separate what you're doing into different lines. Take it one line at a time, visualize what you're doing at the exact same time as you're doing this. and then let each line do something different.
Okay.
There's other ways that you can probably, maybe write like 4 different lines of code on one line, but that's a little too out of scope right now. Maybe just take it one step at a time, right?
Okay.
And then I feel like that'll help you in the long run.
Awesome. Thank you.
Yeah, no problem. The variable is the issue. Yeah, it was the issue, but because it wasn't actually adding it and saving it into that variable. But at least now we have this taken care of. But hopefully that
Mhm.
answers your question, Johnny.
Yeah, dude. Thank you.
Yeah, no problem. All right, we're gonna go ahead and stop there, guys. Let me go ahead and stop recording.